So this is my tree. Okay, so this is my tree. This is my binomial tree. Okay, so as we know, so these are our 10 nodes. Okay, so now we know that we have a call option, and the option we will exercise, and the strike price is 120, and only some of these options will exercise in the money. Now I'm going to calculate the option payoff over here in one step below. The option payoff I can calculate as max of one. In this case, in this state of the world, it's going to be 145.05. Okay, minus the strike, and the strike is here is for us is 120 minus this particular strike. Okay, comma 0. Okay, so I make in this case my option payoff is 25.007. Okay, so that's what my option payoff is in this particular case. So let me use a slightly different code. So these are my option payoffs. Okay, so these are my option payoffs at the end of 6 months. I don't make here anything 0 0, all are zeros. Okay, now to find out the value of the option over here, what I need to do is this. Okay, firstly I need to calculate what is the chance that from 141.86. Is this clear so far what I've done? Giri, Sundara, is that okay? Yeah, thanks. Okay, so basically these are the possible states of the world, and you know, if this from 116 it going to 145, the probability is quite low. It's like, you know, I have to have 10 heads, you know, heads after heads after heads, and every time it goes up, only then I reach 145.07. Okay, and however, you know, these probabilities are a lot more easier. Okay, I could have gotten these numbers just to check that my numbers, these values are right. I can use just a simple binomial distribution in Excel. I can use something called as a binomial okay, binomial distribution. So the number of trials, is 10, is n. Okay, is 10, and the number of this one is a zeros trial. Okay, and okay, I'll do this just after I've calculated the probabilities. So this is the up move, this is the down move. The probability of up move, PU, probability of an up move, we know is equal to e to the power RT. So let me calculate here e to the power D. So before I do PU, let me calculate e to the power e raised to R dt. Okay, so that is equal to exponential R is 0.25%, is a very small number, is 0.25%, 0.25% into dt, which is 0.005. Okay, so that's R e to the power R dt. Okay, so PU is equal to e to the power R dt minus D divided by this whole thing divided by U minus D. So U minus D. This is the probability of the option of the stock price of the energy price going up, and PD is just equal to 1 minus PU, equal to 1 minus PU. So this is the probability of the energy price going down, 1116 going down. Okay, 116 going down. So with these probabilities, I can essentially calculate I can present value these options. Okay, so from 1414, if I were to find the value of the option over here, that is going to be equal to this payoff, and that payoff will happen with a probability of only PU. Okay, plus this payoff, and this payoff will happen with if it were to go from 141.86 to 138.72, which is a down move. So that times PD. Okay, so this is the expected value of the option, and now I need to discount it. Okay, so I divide this by e to the power RT, which I have over here. I discount it, so that is the value of the option over here. Okay, so that's the value of the option over here. Okay, so I'm going to do this. I mean, so I'm going to put the probabilities, you know, and the discount factors, and now we can calculate the value of the option for all these cells, all these different states. Okay, and similarly I can do this for each node, and I'll be, when I come back, when I'm here, I should get roughly around 4.7. Okay, once I've done this, we'll go through the steps one more time very quickly. So I need to calculate for this also. Did I do all the 10 time steps? So maybe I need to do one more time step, I suppose.